Okay, students. Today we are going to start very big lesson. It's called force. And not only force, the lesson name will come up with force and motion all together. Force and motion. So I am going to firstly give you the very background detail related to this one. Okay, background details related to this lesson. Okay, give me one sec. If you can find out certain bottle like this, it will be really helpful in understanding this one. Okay, don't move somewhere. Just ask someone in your family to bring you a certain empty plastic bottle. Small one is enough. Whatever small plastic bottle or something. Right, keep it away. And I want to give you some basic idea about what is the force. First of all, in this lesson, we have to understand the nature of force. Since the entire lesson is based on force. Okay, I am going to explain you everything in detail about what is the force. Okay. Uh, what type of thing, as you know about force? You know that thing in O level. In grade 10, you learned to some extent. I'm not expecting you to repeat the same thing what you know, but better if you can remember something and tell me. What is your idea about the force? Do you have any idea about the force? Any idea? Can you just replicate the idea you have about force to me? Anything? As you know, I don't need any complete and yeah, it is a push or pull on an object, push or pull. Okay. Mhm. I just sent you a certain document to read. Nick. That is not my main tute. This is going to be my main tute. Okay. It is a big one. I sent you some, my regular students know that I normally send them a certain document to read before joining to the class. Addition to the main very big tute, right? It consists everything, right? Very complete tute that I am providing you. But apart from that, I sent you a certain document that for you to read. If you read first few pages, and I just ask you to read first 5 pages only. The strength given to an object to push over. Okay. See the content. It is a very high quality tute that I provide as the very main tute. Okay. All my regular students will get new ones even. So this is going to be the tute, main tute. Apart from this, I sent everybody a certain soft copy of a tute. Okay. If you read that one, you would be able to understand very basics of forces. Just excuse me for 1 minute because many students are here. Just dropping messages. Might be asking for the link. Just give me a 1 second. Mm-hmm. Yeah, this one. Didn't send me the link. Okay, just give me 1 minute. I have to send her the link. Yes, the link. Give me 1 second. Unfortunately, that link hasn't gone to that student so far. Yes, then. Okay, fine. Okay, Ramai, let's back to the topic. So I'm going to teach you the very basics of force. Okay, I asked everybody to find out a certain empty plastic bottle. I will tell you where to use, but when to use. Right. Now, all this bottle within your hand, I'm asking you to just push this forward. You could easily push this. and I'm asking you to pull this towards you. You could easily get pulled. There is another thing you have to do. That's why I asked you to kind of like have a plastic bottle. Glass bottle will not help you in the last thing. Then you saw it is moving pushed forward and pulled back. While it is pushing forward, I am going to do something different. Now I am going to apply another force just to side of this one. What happened? This one was supposed to go like this. All of a sudden, I will show you like this. This is supposed to come forward, but I'm providing a force to here. You will be able to see it is moving to some other direction. What had happened here? Firstly pushed, then pulled. In the last step, I changed the direction. So that force has the ability to change the direction as well. Right. Is that all? No. Now it is moving at a constant speed. Yeah, but I am going to apply a force and speed it up. We used to call that increasing speed in another word. What is that word, my dear students? When you increase the speed of an object moving forward, what is the word that we call? Hello? What is the word that we call? That is acceleration. Very good. It is we can accelerate an object if we can provide the force. Okay. Now I am going to do another thing. It is moving faster at the beginning, then I slow it down by providing opposing force. This hand, try to push it back. Okay, thanks to this, my second hand, it is stopped. That means speed down. Speeding down means the force can just decelerate an object as well. Right, okay. What is the last thing I am going to explain you? The last thing that I'm going to explain you is only for the plastic bottle we can do not to a glass bottle. You can just squeeze. Once you squeeze, it is no longer in the previous shape. See, it got squeezed. What is the last thing? What is the last thing that a force can do? Tell me. Just drop me a message. Yeah. Okay. Very good. Very good. Hmm. Okay. In the physical class today, I asked my students to just pull the nearby student. Just push the nearby student. Then I asked one dude to move forward. Then I just gave him a sudden shove. He just thrown away. That is the change of direction. Then I asked, gently push your friend's face gently. Then you can see what change of shape of the face. That means force can act certain force on it. So this is the best demonstration we can have. That means the force can do what? Push, pull, change of direction, speeding up and slowing down, as well as what? Change the shape of the object. Understand? Okay, this is the nature of a force. Now, my dear students, start to give a very big topic, that is force. Write a very big topic, force only. Write a very big topic, force. It is a huge topic, right? Force. Okay. Okay, Ramai. Okay, let's write the definition of the force. Let's firstly write the definition of a force. Okay. First of all, for my new students, I would like to tell you something. For my older students, know how to write a definition. Definitions are really important. We used to write a star point, but the star points are only for important points. But I would try to remind you something. Definitions are not only important, definitions are extremely important, ultra important. So, how to write something ultra important? I normally use a hashtag or I normally use a dollar sign. Whatever sign you like, just use because definitions are extremely important in physics, chemistry, biology, even in mathematics and any subject in A level. Definitions are completely extremely important. So use any of these sign or any specific sign for you and write what I'm telling you now. Now start write. The influence, the influence caused, the influence caused by an external factor, an external factor, the influence caused by an external factor which can, which can do what? Don't write what? Which can change the states of motion. Change the states of motion, which can change the states of motion. Okay, which can change the states of motion. How? Which can change the states of motion and change the shape of an object. Change the shape of an object. I'm demonstrating that for the very last time. Push it, pull it, changing the direction, and accelerate, decelerate. These are all changing the states of motion. If something is staying like this is the states of motion. But what is the state of motion now I am showing you? What is the states of motion now I am showing you? This is about stationary position or at rest. Now it is a uniform velocity. But changing means you have to accelerate, you have to decelerate, you have to pull it back, and you have to turn it, or you just need to change the shape like this. A force can do multiple things like this. I'm pretty sure you understood what is the meaning of change of states of motion. I'm pretty sure you understood that. Emani? I believe you understood the change of states of motion and the change of shape. Okay. The force can do certain things like this. Okay, very good. Now, right, in the definition, we only wrote the very basic things. Now, right, what are the things we can do? Now, right, in a new line as a small subtopic, a force can do following things on an object. Okay, as I told you, you can just imagine there is a football lying on the ground. And now a Portuguese man, Cristiano Ronaldo, kicking the ball by applying a certain force. At the beginning, the ball was not moving anywhere. Ball has the velocity of 0 initially. Before, this is before. And after. After what happened? After Cristiano Ronaldo kicked the ball will begin to move forward. It will gain a certain velocity after. Okay. The first thing, right? If you want to draw the diagram even, first thing is can move An object which is at rest can move an object which is at rest. Just write it and draw if you want. Draw if you want. Best example is Cristiano Ronaldo kicking a ball. Not only Cristiano Ronaldo, now I am going to do the same thing. I am going to punch this. That's it. Okay. Draw this if you want. Otherwise, it is a very simple thing. You don't want to draw even. Okay. Now, as I told you, the Cristiano Ronaldo hit the ball. There is another guy here in front of the ball. That person's name is what? Our goalkeeper. GK. Goalkeeper. The ball is coming towards him. He do what? He does all the ball like this. It was moving towards him. He instantly hold by how? Applying a resistive force against the direction of motion. Resistive force means the ball was trying to move to here. Then the football goalkeeper comes and it was moving towards him. He applies some force against it and he could stop the ball successfully. That is not only for football keepers. It is for cricket wicket keeper, Kumar Sangakkar. He's just waiting for the ball to come. Then the batsman leave the ball. Ball comes towards him. He catch it like this. So if you apply any force against it, you can stop the motion of an object as well. Okay, write that thing in your writing book. Second point is, can stop a moving object? A force. Second point is, a force can stop a moving object. Moving cricket ball before. After what happens? After the ball will be caught, getting caught by what? Wicket keeper. He will hold the ball. Applying a force against. Force applied against motion. Force applied against motion. He apply a force against the motion and he stop it. Now what is this? Before moving on cricket ball, after applied force against motion, ball get stopped. Ball get stopped. Okay, I hope you understood it. Okay, Lamai? If you want to, you can draw this. Don't draw the nicest hand you can draw. Just draw a simple hand. Simple wicket keeping down. I don't need artist here. If you have an artistic ability, I would really appreciate it, but not for the physics lesson. Okay. Just draw enough to understand it as an object. That's it. Now write the next point. I think I gave you enough time. I will give you another 20 seconds more. Copy this. Can accelerate an object. Can accelerate an object. Can accelerate an object. Okay, let's analyze how it was before. Before, the object was moving at velocity of u. Velocity of u. Okay. Now let's see what would happen to it after. It increased the velocity to certain v value after. So this was all done by applying a certain force of F. Okay. So that means you were just moving slowly, all of a sudden you push it hard, it comes very fast towards you. That is because of this external force. It could move the object from a very slow velocity to high velocity. Copy this. Okay. Okay, students. I think I gave you enough time for you to copy this. Very simple diagram it is going to be. Now write decelerate, or in a bracket write slow down. Decelerate, in a bracket, slow down an object. It is the opposite of this. It was a high velocity. Now the velocity dropped. Now the velocity dropped. All because of what? It is not a supporting force. If the object is moving towards here, the force is trying to push to the other way. See, object is trying to come to my face. It is like an enemy who is trying to attack me. Now I hold his hand. What do I do now? I try to push his hand away from my face. So it is a resistive force. We get decelerate. Can you understand? So draw it. Now write change of direction. Now the next point is change of direction. Okay, it is a cricket ball. That cricket ball is coming towards the batsman before. What does the batsman do? Batsman hit the ball by applying a force of F. The ball now move in a different direction. Initial direction. Final direction. It was trying to go along in this direction. Now the bat apply a different force. It changes the direction. Okay, copy that. That's what the cricketer do. He wait for the ball and he hit the shot and change the direction. Okay, Ramai? Copy it faster. It accelerate, decelerate, change in direction. Now the last thing we are going to write for this one. Last thing we are going to write for this one. Now write the last one. Can change the shape of an object. Can change the shape of an object. I am going to erase this line. It is a simple diagram you can draw easily. Now there is a small aluminium certain sprite thing, and you are going to apply a force by a hammer before. What would happen to this one after? It would get crushed. After being struck by the hammer, now it is no longer in the same shape. After shape change. It is a very simple thing. It is a very simple concept that you can easily understand. Okay. Quickly. Okay, Ramai. I hope you have copied it. I will give you another 20 seconds. Aluminium drink can tin. Then the beverage tin has changed the shape all because of this hammering. Shape changed. I hope you understood it very well. Okay, Ramai. I am going to move to another topic. Before that, I would like to get to know whether you understood this one well. Now I'm going to ask you what are the things that a force can do. First of all, what is a force? Force is an influence created on an object by an external manner. You have to include these 3 points. An influence created on an object by an external manner. How? By an external manner. To change the state of motion. I told you what are the state of motion. Changing, start move motion, stop motion, accelerate, decelerate, change of the direction, and change the shape is a different one. Change the state of motion and change the shape of the object. Okay, we get to know all of this. Now it is about moving to the very next point. But before writing anything, I would like to ask you a question. How many types of forces are there in the universe? Forget about the universe, in the world. How many types of forces are there in the universe? Can you tell me how many types? Basic. There are certain basic types. I am not telling you whether it is 2, 3, 10 or 5. Nothing. Tell me the number of forces. Basically, we can categorize it into basic. I don't know. As I think it is 3. Okay. It is a good answer. Okay, others? Very good. Sanula, Bismuth. Bismuth. Oh. Bimsat නේ. Bismuth කියපුවා මම බලනවා මේ Element. It is an element. So Bimsat. Okay. 4. 3 no. 4. Yeah. Actually, there are 4 forces. No, not 7. Definitely no. It is a wrong answer. It is a wrong number. 4 is acceptable. In the universe, actually, all the forces are only 4 types. But in the mechanics, we know only 2 forces. Yes, all the forces can be divided into 2 types. One is contact forces, other one is non-contact forces. Okay, let me give you a really good example. Okay, listen to this one very carefully. Don't be hurry to tell me the answer. Okay, there is a very small girl. She's like age of 5 years old. She's a very cute little girl. Okay, this is that 5 years old little girl. Oh, she doesn't look like 5 years old. Seriously? Ah, 5 years. I will write. Okay, 5 years. 5 years. Okay, 5 years. I wrote 5 years old, very small girl. She's so cute. Then when anybody see a very small cute kids, what do? They normally squeeze their faces like this. I just squeeze them. There is an advertisement. In that advertisement, they just squeeze the face of the child and say, "Kuchi kuchi shop." So I would say, okay, kuchi kuchi shop, little girl. So I applied a force. It changed the shape of the face. That's how I say kuchi kuchi shop. Is that a contact force or non-contact force? Tell me. It is definitely a contact force. Okay. Contact. Very good. Adi. It is a contact. Now there is a certain 18-year-old girl. She's a TikToker. She does some TikTok. And I'm someone really hate TikToks. Okay. Then imagine I have a certain catapult ordered from Daras. It is a very good one. So I install a very small stone. So a small one. And I targeted at her, hit on the forehead. Imagine I am a very bad man. I do like that. Now this stone just hit her head. So now tell me whether the force is, it definitely hit like this. Now tell me whether the force is contact or non-contact. Because I am at here, the stone ball and hit her. Is that a contact or non-contact? Tell me. Okay. Okay. I hit the stone. Thrown. It is not in my hand. It is not in my hand. But it hit on the girl. It is not in my hand. Okay. Is that a contact or non-contact? I'm getting very nice answers. Okay. Non-contact, 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 contact, non-contact, again contact, contact, non-contact, and contact. Others? Okay. Another one say it is a contact. Non-contact again. Contact again. හොඳට හිතන්න. आगे सोचो हिंदी कीवर्ड. Think more. It is contact force. It is not a non-contact. Because this one is not in my hand. But there is a physical thing hit the girl. There is a physical thing hit the girl. If this is the stone, it hit the girl. It is a physical thing. Two physical objects collide each other. It is a contact force. Okay, even though it left my hand, but still the object reached to the girl. If there is an interaction between two physical objects, it is a contact force. Normally, majority of the students used to say normally like non-contact. Those who understood really well, who said only few students said it is a contact force. It is definitely a contact force. Can you understand? Can you understand? Now give me a simple definition of a contact force according to your words. I don't need any bomb blasting words. Simple and sweet. Your own definition of a contact force. I would like to see. I normally give the opportunity for my students to show their class. So, okay. Hitting someone. Collision of two physical things. Okay. Tell me your idea. Okay. When something touches something else is a contact force. Okay, good. Bismuth. Force act between two physical objects. Very good. Colliding of two or more physical quantities, not quantities, my dear. If force applied in a contact with the object, then we say that is a contact force. You are really smarter than I thought. Many students got some really good answers. Okay, enough of writing answers. Now I'm going to tell you what is a contact force. Don't write. I will give you writing time later. The force occur between two surfaces in contact. Two surfaces in contact. Okay. Because of a collision. Because of a collision. Two surfaces in contact and force created all because of a collision. It is what? Contact force. Okay. So how about a non-contact force? Non-contact. But let's go for non-contact force later. But I'm going to give you a few more examples. Now there is a tree. Now there is a tree. And there is a ripen mango. And there is a very long stick. It is attached with a certain hook like this. We used to call a kekka in Sinhalese. So I am going to pluck a mango. So I'm holding it at here. Now tell me whether this one is a contact or non-contact. Is that a contact or non-contact? It is definitely a contact, my dear. Because why? Even though I'm holding it here, my force is applied. Now it is an interaction between this hook and the mango. Two physical objects collide against each other. These two are in contact. So that means it is physical, two physical objects colliding. So that means what? It is a contact force. Okay, how do you look at it? Now, there's another man, very stingy man. He doesn't like to let an animal to eat the fruit even. Now he has a what? Lychees plant, very lychees means rambutan. Okay. Now that man holds a thing called takea. And there is a string coming from that one. He has just put an end even to his bed. While he is in a sleep, he always pull the thing. Even in his dreams, he pull the string and he keep doing what? Take hollow. In the night even, he keep shaking the take thingy. To do what? Scare animals who may eat the things. But it is like a bell. So this one work all because of the tension provided by the string. Now tell me whether this force is a contact or non-contact. Whether this force is a contact, again saying non-contact. It is a contact, my dear. It is a contact. Why? This string touch your hand as well as the kantara, that means like the bell thingy, take thingy. The take thingy begins to hit against the bell, covering all because of this force. It is a contact force. It is a contact force. Understood? Say yes if you understood. It is a contact force. Now, enough. Okay, I said many examples of contact forces, but you might be worrying about, oh my God, sir, you said many contact forces, but you didn't say anything about an uncontact force. You might say like, you are a bad man, sir. Very good, Babazara. Very good, very good. Others? Now, if you know, tell me non-contact forces. Tell me. Babazara told me a one non-contact force. Very good, girl. Vidusana, correct. Apple falling. Okay. I got two non-contact forces so far. Third one, nobody told me yet. Okay. I'm going to tell you live example. Oh, yes, Vidusana, you told me the third one too. Okay, now. Now, there is a certain beautiful girl. Okay. There is a guy. He tries to attract that girl somehow by just charming her. But the problem is the girl pay no attention to him. He's very upset. But I would go close to him. Don't worry, dude. She already attracted to you, I would say. Even though the girl doesn't like him. How? Because I have a physics thing to tell him. Then I say, dude, don't worry. Girl is gravitationally attracted to you. Gravitationally attracted to you. That's what I say. Then he gets really elated and he will go towards the girl and say, hey, even though you don't like me yet, you are gravitationally attracted towards me. If the girl knows physics, she would say like a chat, how? My friend, gravitational force is negligible. Then he has no answer. Why? For the gravitational force, only requirement is only two objects. Only two objects. If it is as small as an electron, as bigger as like two stars, whatever an object in the universe, this marker pen, the yellow one and the blue one, would you believe these two are gravitationally attracted towards each other? I'm not telling about falling of this one. It's because of the earth. I'm telling you because of themselves. Because of themselves. So the green one and the blue one are attracting towards each other. But it won't come towards each other. Why? The girls respond. What is it? The force is negligibly small. Can you understand? So one force, one type of non-contact force. I told you, what is it? It is a gravitational force. Understood? Okay. Now that guy is really angry with the girl. Now the guy is really angry with the girl. He's like a very bad guy. He somehow asked his friend to wrap a metal sheet around her, certain metal sheet around her and tighten he hold a very big magnet. Very big magnet. Now what happened? The girl get attracted towards the magnet. What type of force it is? He's just getting the revenge from the girl. It is the magnetic force. Can you understand? Now, he just removed the metal covering. He put another magnet. Imagine this one is in North Pole. This side is again in North Pole. Now the girl get repelled away, thrown away. It is magnetic. Okay? Right. Now I am going to tell you the third type. Those TikTokers, those TikTokers are really kind of like brainless. Most of them, huh? Most of them. I'm not telling everybody. Even I'm brainless and I do TikToks. No, I don't do. Okay. Now two TikToker couple, they are just moving out and in a camping thingy. They were just doing a kind of like live TikTok video or something. All of a sudden, it's about to rain. They are in a hilltop. Then the guy's hair, all of a sudden, goes really up like this. Without waxing, without doing any gel or any application, hair goes really up, right? He just kind of like live extreme that, and with the girls hair also goes up. They say like, oh, there is a certain miracle happening. Even without applying any wax, my hair goes really up. He's doing his last one. His last TikTok live video for his life. Why? Why would you think that? Why? Yeah, it is because of electrostatic force. He's nearly about to get lightning strike for this dude. Now he's getting the third type of non-contact force. He's just about to get the third type of non-contact force. His hair has gone really up because of this cloud, right? Now say he's just going to get lightning strike. He's just filming his last TikTok video. Actually, two guys, actually not a girl and boy, two British guys, they were doing a live video. They say like, hey, my hair goes up. It's a miracle like that. And they got instant lightning strike and died. You can just search that in the YouTube and find their last video. Whenever you are moving in a certain plain area, it can be a ground, it can be a mountain top or a paddy field. If you feel like your hair goes up, instantly lie down. කෙලින්ම ආයිත් හිතන්න එපා බිම් බුදිය ගන්න. අකුණක් වදින්නයි යන්නේ. තේරුණාද? I told you all three possible non-contact forces. What are the three non-contact forces, my dear students? Gravitational force, electrostatic force, and magnetic force. These are the three types of non-contact forces. Understood, my dear students? Hello? Enough name? Now it is better for you to write the things. Now let's write list of contact forces. Contact forces, small subtopic. Contact forces. Forces. Let's write few examples. Okay. Just write one example. Applied force. Applied force. I will tell you what is this applied force later. Applied force. Number 2. Okay. Students, this is actually our founder of the institute. He's Nirosan Prasanta sir. I'm going to invite him to show you some important demonstrations. All this from this end. Okay, this is a certain rod. I am going to pull this, sir, pull to that side. Okay, we are pulling, right? We are applying a pulling force. Now I'm pulling here. Okay, it got pulled. Now you pull. Okay, it get pulled. So now tell me, what is this type of force? Pulling force is always used to call as what? It is a tension. Okay, sir. Yes, now push towards me. Thrust. Yeah, thrust. He is going to thrust towards me. Push it. Okay, it get pushed. It get pushed. Now I'm going to push it towards you. Okay. Now can you see? When I'm pushing, I'm going to show you. I am always trying to push the force by through this one towards him. All this. Okay. So now where am I going to apply the force on him? Like this. Okay. Towards him. So always the thrusting force towards the man or the object, other object, pulling force. Now try to pull me, try to pull me. Okay. Now he's trying to pull me. All the pulling force always try to pull me. Pushing force, try to push me. Pulling force, try to pull it. Okay, you can see the arrow moves to there. That means it is going to pull my hand. So you can, thank you very much. Okay, now I am going to write the other type of force. Uh, tension. Tension. He was doing his maths class in the adjacent classroom. I just asked him to come and because I just needed someone to demonstrate it. Tension. The third one is what? Compression. 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 Number 4, reaction. You might be hearing most of the words for the first time in your life. The next one, upthrust. Upthrust. Okay. Applied force, tension, compression, reaction, upthrust. And let's learn the very last thing we need for the mechanics mostly. What is it? Friction. Friction. Okay. Shall I tell you a really simple example to you? Normally, there are many people in different religions, right? So in Sri Lanka, Buddhists, they actually worship, people might think they are worshipping the Lord Buddha. Yeah, Lord Buddha do. But the ultimate worshipping factor is to something called Dhamma, Lokapalaka Dharmaya in Sinhala. That means it is like a certain software, it controls everything. They don't call it like a personal wise, it takes like a certain system. But in Catholicism and in the Islamic, they are just worshipping the same God in two different names, as I know. Right? As I know, I don't know. So normally two different names, but for the same God. And Hinduism, they call like worshipping someone called ultimate goal is to worship what? Brahma. But in my perspective, I think all of them are the same. We just kind of like worship to certain supreme power in our own cultural way. That's how I think. Whenever I see a mosque, I feel really happy about it because certain supreme power is worshipped under their own way. In the Christian church, Catholic church, and the Covil and everything, I think they just worship the supreme power. But so somehow different gods have different names, like in Greek gods also altogether. Okay, but altogether we know them are gods. So like here, we have to know specifically certain things are as forces. Let me tell you why. In sometimes certain things like here I will mark many different forces like mg sine theta, frictional force, and tension. And you may ask many students who coming from different classes, they don't have the primary understanding. They may ask, sir, why did you add them? Why did you put the unit as Newton for tension? They ask frequently. Why did you put the unit as Newton for upthrust? They ask, why did you put Newton for the normal reaction? Why did you put Newton for friction? Oh, the reason is they have not observed the real gods of force. But these forces, these are forces. Firstly, we have to know. Okay, it is like worshipping a devil, considering him as a god. It is a wrong thing. And we get afraid of a god, considering him as a devil. It is also wrong. We have to worship the god and get away from the devil. That is how we should. So, like here, we have to firstly identify forces, treat them as a force. Okay. Now, write this as a list. Contact forces, applied force, tension, compression, reaction, upthrust, friction. Enough. Write these. I will explain you each. Okay, quickly write this. Okay, Lamai, quickly copy. Applied force, tension, compression, reaction, upthrust, friction. Enough. I hope you have covered this thing. Yamane? Very good. Now we have to go for last thing. Now, right? Non-contact forces. Non-contact forces. Non-contact forces. Now you know the three names. Now you know the three names. Let's write. Number one, gravitational force. Number two, magnetic force. The last thing is electrostatic force. Electrostatic force. Copy this. And by the way, I have to tell you an important thing. We are not going to learn these three things in this lesson. There are three separate main lessons for gravitational force, magnetic field, and electrostatic field. There are three different future lessons. Even 2025 students has not touched these things apart from gravitational force. Magnetic and electrostatic are yet to come for them. So you have a long time to go to learn them. But gravitational field you can learn within like another 4 to 5 months from here. Right? It is a very small lesson. We can finish within 2 days. Okay. We are not going to touch anything in that for A level. Sorry, mechanics. Okay, Ramai. Now, firstly, let's try to identify Basic types of forces. Now write the first example as weight. Weight. You mention it in W or mg, and the unit is in Newton. It is a force for weight. Okay, Ramai, quickly. And write the definition of this one, a very small definition. The product of mass and gravitational acceleration. The product of mass and gravitational acceleration. Copy it. Okay, Ramai. Copy this one. Now write the next one. Next subtopic, tension. Next subtopic is tension. Tension. Symbol is T and measured in newtons. There is a ceiling. There is a rope. And a guy is hanging. Is that what? No, 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 no. You just hang a cricket ball and you are going to play on it. Okay. Now the weight of the cricket ball is downward. Now there should be a certain force to balance this. Okay. The weight is just to what? Trying to pull this down. Pull this down. My right hand act as if the weight. Okay. My left hand act as if the tension. So when this one is trying to pull this down, according to Newton's third law of motion, according to your grade 10 knowledge, this left hand act as if what? The tension that act on my hand, so it is pulling this thing up. Okay. So the tension is applying a force on this object always inward. So remember that tension always marked into the rope. Into the rope. Markings. Before marking anything, just write this in a triple star point. Tension occur in strings as well as rods. Strings as well as rods. Copy it. Copy it. Okay. Tension act on rods as well as strings. Okay. You mark the tension always into the center of the rope. Okay. Now tug of war. Now how can you mark the tension force? How can you mark? Okay, like this way, like black or in the green. Tell me, is that the green one or the black one? Tell me, is that the green one or the black one? Correct. Which one is correct? Green or black? Correct. Mm-hmm. Mm-hmm. Okay. definitely green one, it is always towards the center of the rope. This is how you are going to mark tension with key. Okay. Now there is a ceiling, there is a wall. I am going to attach two strings like this. One string to here, another string to here. I am going to pull this string down to ground. Now each three strings are fully tensed. So I can mark the tensions like this way. Okay, always inward. Tension of the first string, tension of the second string, tension of the third string. Okay, mark it like this. It will be really useful in your future. You will use this type of things a lot. See, different ropes and systems. So it is very important to understand this one. Okay, Lamai. Mark it. Tension T1, T2, and T3. Very good. Okay, Ramai. Okay. Copy this one. Can you understand this one, Lamai? First string, it is T1 string force. In the second string, T2 force. Third string, T3 force. Okay. Okay, I'm going to erase. So tension is something like this. We are going to find many tension forces and magnitude and many more in the equilibrium lesson and in the Newton's second law. We are going to calculate these things. But before, you have to firstly understand the nature of tension. We will do thousands of tension related calculations. Okay. Right, my dear students. Write the very next thing. Tension. Now write reaction force. Don't write reaction. Compression force. Compression. Now I keep a big object on a certain rod. Mass. Weight applies downward like this, mg. Now weight is trying to do what? Push this downward. Okay. So this one tries to push my hand back up, like according to Newton's third law. I put downward, this put upward. So it is always compressive force is marked like this. We mark it with R. So it is a reaction type of force. Always away. Tension is into, this one is out. Tension is into, this one is out. Mark it. Okay, Lamai? You copied it. It is always away. Right. The next point is actually compression. It was compression, not tension. Compression. Compression marked in R and measured in newtons. Now, right, very most important type of force is here. The most. Now, right, normal reaction force. Next subtopic is the normal reaction force. Most important one is this one. So pay all your attention. Normal reaction force. Normal reaction force. It is always act like this. Sometimes we mark it like R. We can mark it like R or capital N. It doesn't matter. Okay, now write the definitions. The type of contact force, the definition, the type of contact force act on two surfaces in contact. Act on two surfaces in contact perpendicular to them. Perpendicular to them. It's like this. One surface, the other surface, one pushes the other. This one apply a push force on the second one. So the second one gives a reaction force, that is normal reaction force, always perpendicular. That means it is always 90 degrees to each other. Okay. Mark it. Mark this one too. Okay, quickly, Lamai. Copy this one and copy this one. When you apply a force, like this surface apply backward force perpendicular. Those two are perpendicular to each. Okay. Now I'm going to ask you a very rational question. Rational one. Okay. හිතලා උත්තර දෙන්න ඕනේ. Now there is a plane like this. It is angled, slanted. There is a box. Keep on it. Now weight is definitely downward. Honey Ramai, I forgot to tell you a certain factor. Please go to weight. Please go to weight. I think I forgot to tell you the factor. When I write this, I remember. Go to force topic and write it somehow. This very triple star point, very important triple star point. Write that in the weight topic. Weight is always act downwards. Weight is always act downwards. Weight is always act downwards. Just write it. Weight is always act downwards. Weight is always act downwards. Okay. Now that point is over. Come back to here. Weight acts downwards. Now I'm going to mark 3 different lines for the normal reaction force. Okay, as usual, upward force as normal. It is N1. This type of force as N2. And this type of force as N3. This type of force as N4. Which one is the correct one? Is that the N1, N2, N3 or N4 correct? Tell me. Which one is correct? N1. Okay, others? Which one is correct? Look at this diagram and look at this diagram and tell me. N1. Okay, others? Another one said N4. Okay, N1, N4, N1, N4, 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 N1. N1 again. Okay. N2, another different option. Okay. N1 again. N4 again. Happy. Keep telling me. N1 again. N2, very different option again. N2 again. Okay, Ramai. I got many enough answers. Correct one is this one. Correct one is this one. Now tell me why it is not N1, why it is not N3, why it is not N4. Most of the students got this answer. Why? IMG downward. This one is upward. You thought it should be N1. No. No. What is the mistake you did? What is the mistake you did? Read that definition of normal reaction force, please. Read the definition of normal reaction force, please. Take your time. Did you identify your mistake? Pehan correct. Anuhas correct. Luxika correct. Many students seem to have corrected their opinion. Why? If you read, you have to understand. Oh my God, huge mistake. Yes, my dear, it is a huge mistake. Huge mistake. Those mistakes are the ones we have to remove for the final exam. We had a decent exam in the last week. Everybody got really shocked. Some students cried. I didn't release the results yet because I told you I'm going to release the result by another 2 weeks. Why? I'm delaying it because I want you to focus on this lesson and just let the exam to be forgotten and get the result in 2 weeks time. Then it will totally 3 weeks. Even after your final A-level exam, you have to wait for your results, right? Good mistake, right? Big mistake. The forces should be perpendicular to the one plane should be the perpendicular to the other. If this one slanted, other one also has to slant. This one slant more, other one has to slant more. If this one is exactly like this one is here. If this one is turned like this, other one has to turn down like this. Always it has to maintain the perpendicular nature. Turn, both turns. So this is the correct option. Perpendicular. Okay. Mark this, please. When you say huge mistake, have you ever watched Night at Museum? A movie called Night at Museum? Have you ever watched? In that movie, famous British knight called Lancelot in Camelot, he just woken up due to certain magical thingy. He then goes to find what King Edward or someone to kill. That play was done by a actor called Hugh Jackman. He said, "I'm not Edward. I'm Hugh Jackman." He's asking, "Who? Hugh Jackman?" He was just what that guy. Lancelot was asking because he's coming from thousands of years back. He asked, "Who? Hugh Jackman? Hugh Jackman?" So you said like huge mistake. I remember huge Jackman. Okay. Now, okay. Now, have a good look at. There is a vertical ball. I am going to push this object by using a certain force of F. Now tell me, where should the reaction force be? I will mark it like this. R1, R2, R3, R4. Which one is the correct one? Think wisely. Which one is the correct one? R1, R2, R3 or R4? Tejan correct. Tejan correct. Others? Tejan got the correct answer. Wrong. Vidusana correct. Dishon correct. Pehan wrong. Sansika wrong. Think correctly. You have to think two things here, not only one, two things. No. Wrong. 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 Correct. Habasara correct. And Pehan correct. Wrong. Wrong. See, you have to understand everything. Wrong. 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 Pavani correct. Pavani correct. Malisi correct. Himasa correct. Generally correct. Okay, I'm telling you what is your mistake. I told you This is the first plane. The black one is the second plane. So those who say R1 and R3, they should be crucified. Anivaryamma ellam doni. Hari? Because why? It should be perpendicular. This is along the plane. Perpendicular, the wall. I should hit like this, not slanted. Perpendicular. Like this. Directly. Okay. Now there are two perpendicular things. Here and here. Out of these two, which one is correct? R2 or R4? I am asking again from the wrong ones. R2 or R4? It is R4. Why? This is the force you are applying. It is like I am hitting the wall slowly, otherwise it will break. Okay. Then the wall gives me a reaction force. This is my force. Wall gives you reaction. This is the reaction. This is the correct. This is not correct. Copy this one. There are many things to think, ne? This is why I am telling you, physics is something you have to touch here and understand. Okay. Copy this one. Mark all of these. Wrong, 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 and right. Like that. Okay, Lamai. Quickly. Quickly. Now, can you understand why it is 4? I am explaining you again. When you apply a force to certain direction, when it collides, the reaction always comes against that. Against that. Should be perpendicular, definitely not these two. This is not because it is in the same direction. Reaction means it is opposite. Reaction means reaction. It is the opposite action. Reaction. Now let's check your beautiful IQ level. Now it is a question. Find out the effective reaction force in the following. Effective reaction force in the following. There is a 50 Newton force act downward. There is a certain reaction force. I am applying another 30 Newton downwards. Tell me what is the value of reaction force, please. Draw this as the example number 1 and find it and tell me. Dishan correct. Anuhas, Tejan wrong, and Sneha correct. Yes, 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 yes. It is about equilibrium. I didn't say anything about equilibrium yet. I didn't say anything about equilibrium yet. It is a future lesson. But for your general understanding, correct, 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 correct. So actually the condition should be, it should be not motionless, equilibrium. Equilibrium means moving at constant velocity or velocity should be zero. These two conditions. It is not motionless. So I will tell you in the future. But from your simple understanding, if this is motionless, it is if it is like a what certain object remaining like this, not moving. Okay. So the thing is, I am going to mark the forces. 50 Newton downward, R upward, and 30 Newton downward. There are two things down, only one thing up. So reaction is what? 50 downward plus 30 downward. So the reaction is what? Upward 80 Newton. Reaction is 80 Newton. Mark it. Reaction is just 80 Newton. Okay. Reaction is just 80 Newton. Understand? Yeah. Now I'm going to remove these numerical values and I'm going to apply certain kind of like algebraical symbols and develop it, and you have to try with algebra now. Okay. Let's see. I am modify the same diagram now with mg and just an F force. Considering this is motionless, system is motionless. Okay. Now try to find out value for R in terms of algebraically. Now tell me an answer. Okay, very good, very good, very good, very good, very good. Everybody understood it. Very good. Vidusana correct. Anuhas, Genuli, Pehan, Pavani, Luxika. Enough, enough, enough. I'm not checking any more answers. Mg downward and Fp is also downward. R equals to Mg plus F for B. Okay. Okay. Now I'm going to give you different example. And just give me a 1 second. Okay, Lavani? I hope you just understood this. Okay, let me just develop this. Considering the system is again balanced, now I'm going to apply a force 50 Newton is still downward. It is a 30-degree angle and the force is 60 Newton. 60 Newton. Now try to find out R reaction. Now try to find out R reaction. Simple modification done. Just try to find R reaction. Dishon, rethink. Vidusana, correct. Vidusana, correct. Dishon, rethink. It is 60 Newton. Apply at an angle of 30-degree slanted to the horizontal. Tejan, think 100 times. Think 100 times, not just think 100 times. Okay, Ramai, quickly, hurry up. Okay. No, 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 no. Okay, Ramai, I am going to do it now. Okay, many students seem to not to understanding it. Okay, think this type of motion in a real life example. Okay, in a real life example, so you guys just go to what it is such a, but you guys goes to supermarkets and hold what those carts like this, and you keep pushing. You just keep pushing it forward, putting certain force, but slanted like this. Emily, in a regular supermarket cart, you put all the goods in it and you push it to the handle like in this way. You push it actually downward with a force. It has its own weight, and these from these tires, the wheels, it will put certain R1 and R2 reaction forces. Can you understand? Can you understand? It is a real world example for this type of pushing force. Okay. So, have a good look at here. Now, I will just simplify this as a free body diagram. I have not taught you free body diagram yet. That means I can just shrink this object to a dot. I will teach you this free body diagram method in the next week. I have not taught you as a theory, but I am telling you to use this entire object as a small dot. Now there is a force like this, 60 Newton, but it applies in an angle of 30 degree. And the weight is 50 Newton. Now my problem is, I have to resolve this force horizontally, but when you have a force like this, 60, and the angle is 30, how it is going to be? 60 cos 30 The force is what? 60 cos 30. It looks very ugly here. Let me go for the other side. When you put certain force like this, 60 Newton, have a really good look at. It has an angle of 30 degree here. Right. You learn this type of forces, vectors. When you have a vector like this, when you have an angle like this, you learn the cross side. I told you to my students, cross side is cos. I told you, ne? Huh? You have to remember. I told you, ne? Cross is cos. So we cos theta. The open side, which is not in contact with the angle, we sin theta like that. So 60 cos 30 and downward 60 sin 30. Okay. Do I need this component? Horizontal one? No. Because I always need perpendicular ones to the plane. So I need this one. So I redraw the free body diagram now. So the R reaction should be here. And R reaction is here. Right? There is a downward force. What is it? 60 sine 30. 60 sine 30. And mg is 50. 50. Now what is 60 sine 30? 60 sine 30 means 60 into half. It is 30 because sine 30 equals to half. Because sine 30 is equals to half. I am going to substitute it over here. Now the value becomes, again simplified, 30 Newton downward, 50 Newton downward, upward is only R. So what is my R now? What is my R now? R is nothing but 50 downward plus 30 downward. So my force is 80 Newton downwards. Can you understand? Can you understand? If anybody don't understand, just let me know instantly. Those who understood, let me know. Or otherwise, I will redraw the diagram entirely and explain you. Understood, ne? Okay, okay. I will give you like 20-second complaining time if you didn't understand. Otherwise, you just draw. You just draw everything with the steps. You draw everything with the steps. Okay. This is unnecessary step. Drawing all the necessary steps. This is step, 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 and this. Come on, quickly, hurry up. Hurry up. I need more energy from you. Come on. Okay, Ramai. Now. Hmm. Now I will give you a similar question, but little altered. I'll give you another 30 seconds to complete this. Do it fast. Can you repeat it once more? Okay, I will repeat. I will repeat if you ask me. So have a good look at. Let me draw it more clearly in a big diagram. There is a 50 Newton force downward already. There is a 50 Newton force. There is a 60 Newton force in an angle that of 30 degree. That of 30 degree to the horizontal. Okay. Now you need to find out the value of R. Okay, this is what your challenge. Now for my convenient, I am going to shrink this big object to a small dot. That is called the free body diagram. I will teach you that in a theory in the next week. In the next week, not today. Okay. So, this is the very big diagram. I am going to shrink this to a very small dot. Have a look at. There is a very small dot here. And the force is 50 Newton downward. That is already there. Now there is a 60 Newton force applied on it at an angle of 30 degree. I am repeating the same object without a very big box. And the R, you don't know. This is what you are trying to find. Okay, Ramai? That is what you are trying to find. Now I can't find with this slanted one. I am going to try the slanted one resolved. 60 degree Newton and there is an angle of 30 degree. Okay. I can resolve this cos 60 cos here. It is going to be 60 cos 30. The perpendicularly downward one, 60 sine. Okay, wait. Bottom of it. 60 sine 30. Understand? Okay. I don't need the horizontal one. I don't need any horizontal force. I don't care. But the vertical forces I need. So I will only take this one. Now let me draw the diagram here. It will be R here. It will be 50 here. The other force is what? 60 sine 30. 60 sine 30. What is the value of 60 into sine 30? Sine 30. 60 sine 30 means half. The value is 30 Newton downwards. Can you understand this far? Can you understand it this far? Okay. The last step is I am going to write the real values here. Have a good look at. R I don't know. It is 30. This is 50. Now there are two forces downward. 30 Newton downward plus 50 Newton downward. R is what? 80 Newton downwards. Sorry, R is 80 Newton upward. Against it's against. Okay. Can you understand it? Student? Can you understand it? Can you understand it? I explained in most simplest way. Okay. Copy it. Copy it. Copy it. You have already copied, ne? You have already copied it, ne? Right. I am going to give a different one. Just a slightly changed one. Chuttak venas ekak. There is the ground. There is another box. It has the 50 Newton as usual. I need the reaction here. Now I am going to pull it by a force of what? It is 60° here, 60°, and angle force is as same as 60 Newton. What is the value of R? Try it, please. Try this, please. Vidusana. Rethink, my dear. Rethink. Think more. Rethink. Drop to this device. I'm sending a wild message. Send messages to this device. I can see only in that one. Arrow. Okay. Arrow is upward. Okay. Malisi, you did the same mistake like Vidusana. Wrong. Tejan, rethink. You got the root value wrong. There is no root value there. There is no root value there. Vidusana correct. Tejaswin correct. Others. Tejan, dear, wrong. Look at the direction of the arrow. Look at the direction of the arrow. It is like pulling a traveling bag. When a guy pulls a traveling bag, this is how someone pull a traveling bag. Moves like this by applying a force F, and the weight is like this, mg, and the R reaction is like this. Real world examples, something like this. Pabasara correct, Malisi correct. Tejan finally got the answer correctly. Dishon got the answer correctly. Himasa, my dear, look at the arrow. Look at the arrow. It is an arrow. Rikshigan, very good girl. Oh my God, Pehan. Rethink. Look at the arrow. Look at the arrow. Enough, I think. I gave you enough time to think of it. Right. As usual, I am going to draw the small dot. I will tell you in the next week how to draw this type of one correctly. Right? Correctly. For today, let's draw something wildly. 60 and the angle is also 60. Now I want this one. Here the component is 60 cos 60. Here the component is 60 sin 60. 60 sin 60. I don't need this, but I need this. So finally, I am going to alter this diagram. Okay, I am going to alter this slanted diagram upward like this. 60 cos 60 and upward R here and the downward 50 here. Now tell me what is 60 cos 60? 60 cos 60. 60 into half. So it is 30 Newton. R here, 30 Newton here, 50 Newton downward here. So what is my resultant then? My resultant is going to be 50 Newton minus 30 Newton. R is equals to 20 Newton upwards. Do you understand this? Do you understand this? You committed crime by adding this name. So you can't commit any crime in physics. If you make a single silly crime, it will kill you. So be more patient, more accurate, more presence of mind. We have to practice, no other way. Okay, quickly go please. That is why I told you the normal reaction force is the most important part here. Okay, Ramai. I hope we have done it correctly and more than enough. Let me erase this one. And I will give you a practice worksheet and you have to practice it. So shall I erase this one? So is there anybody who didn't understand? I'm sure everybody understood. There might be a very rare chance that somebody didn't understand. Understood, ne? Perfect. Okay, Ramai. It is step-by-step work. No need to be panic. Do it slowly. You can do within 10 seconds. Once you get proper practice, it will take time. It is a matter of time, not one day game. Okay. So my opinion is do my examples 2 or 3 times before trying a new one. Because in my examples, I give you all the possible scenarios. When you practice that 2 to 3 times, you can get that knowledge to apply in a other question, new question. Okay, Ramai. Let's quickly move on to the next penultimate topic, right? Upthrust. I'm going to give you just a wild definition, not the real definition, because the real definition is sooner to be given in upthrust lesson. Upthrust will be a big lesson in hydrostatics. So this is not in hydrostatic. I'm just showing you this one as a force here. Up thrust and the weight downward. Okay, right. In a simple definition, not the ideal definition, only for this one. This is not a definition, just an introduction. The upward force created on an object by a fluid that the object immersed in. I will give you the right definition in right lesson. This is only about simple up thrust, upward, always acting upward. In newtons, up thrust. Topic is up thrust. You measured in newton. Copy that. That is enough. That is more than enough. Now write the next subtopic. Friction. Friction is also a future lesson. No? Friction is also a future lesson. We are going to learn like 3 weeks, 2 or 3 weeks from here. Today I'm just going to give you introduction only. This is not friction lesson, no? It is just an introduction. Write this. The resistive definition. The resistive the resistive force that prevent or retard what? Motion between two surfaces, relative motion between two surfaces in contact. This is the one surface, my other hand is another surface. Sliding over one another means relative motion. Okay, I will repeat you. The resistive force that prevent or retard. The resistive force that prevent or retard what? Relative motion. Relative motion between two surfaces. The resistive force which prevent or retard relative motion between two surfaces in contact. Okay, resistive force. That's it. This is the applied force. This is the friction force. Applied force means the force you are just going to apply. Applied force. And what is this? Frictional force. Friction. That's it. So we have done type of forces and some good introduction about it. So it is time to have an interval of about 15 minutes. Not 15, 15 is too much. 12 minutes and join back around 10:22 and we are going to do resultant force. Lesson. So please come back. Don't leave the meeting. Just mute the meeting and go. Join Back at where? 10, 23. 10, 23. Okay. Join back at 10, 23. Okay. Okay, Ramai. Just mute and go. No, 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 no. We are going to discuss the paper in a different day, not in a class day, in a different day. I will tell you a day soon. We have to discuss that paper. It's time to restart. It is time to restart. Okay. It is time to restart. It is time to restart the class. Lamai, so as I told you, we are going to discuss the paper in the very next week, not today. Okay, not next week. In a sooner, once I give you the mark, like it will take another 2 weeks because you want to stick to this lesson without distracted by your good marks or bad marks, whatever. If you get really good mark, that means you will get high. So if you get a bad mark, you will get disappointed and this lesson also will be affected. So I will give the marks in next 2 weeks. Okay. So, and I will discuss the paper later. It is a very nice paper. So within another 2 months, you have to face for another exam. So after the first week of January, so I'm not going to do the test between Christmas and January, and I'll leave the first week even. In the second week of January, we will have another test, proper test. Okay, Raman. Now I taught you all about types of forces. So now I'm going to give you another nature of a force. Nature of a force. So a force is a vector. Force is a vector. Now write nature of a force. Nature of a force. Write this in a new line. Nature of a force. Nature of a force. Now write in new line. A force is a vector. Write it. A force is a vector. So it can be represented in a coordinate system graphically with the proper scale. Okay. Imagine you are just getting a scale of 1 Newton equals to 1 centimeter in the scale. So if you want to represent what? 10 Newton, what is the length it should be? What is the length it should be? Tell me. What is the length it should be? Quickly. It should be 10 centimeter. 10 Newton by 10 centimeter, right? You can draw a line like this and mark 10 Newton by what? 10 centimeter. Okay. So copy all of these. Copy all of these, please. Okay. Okay, Ramai. Now, right. Since force is a vector, Since force is a vector, force can be added or subtracted according to a force can be added or subtracted accordingly what? Vector addition and subtraction rules. Okay. Now write a small subtopic. Resultant force. Resultant force. FR, or you can just represent by R. Resultant force. Okay. Now write it like this way. The single force that can be represented, that can represent a system of vector, a system of vector. Okay. Have a really good look at now. Simple example. 4 Newton and 3 Newton. So how to find out the resultant now? Resultant in the same direction. So what can you do for the resultant? You can simply, they are parallel and in the same direction. That means according to vector rules, you can directly add them. 4 Newton plus 3 Newton. It is going to be 7 Newton in the right hand side. Copy this one. Something you have to recap now. What you have learned very early. It is like 2 months ago we learned, ne? Nearly like 2 months. Okay. Now the opposite of this one. I am going to give you the opposite of this. A 4 Newton force and a 3 Newton force. How to find it? R equals to 4 Newton in the right hand side. This is in the left hand side, but we can't write that way. Plus, in a bracket, 3 Newton. In the right, you have to change the arrow by adding a minus sign to here. Because you change the direction of the arrow, so you have to put the minus sign. So minus and minus plus and becomes minus. So the resultant becomes 4 minus 3 R is 1 Newton in the right hand side. Copy this one. Copy this one. Okay, copy that one, please. Okay, Ramai, come on. Now let's have a certain different one. Something slanted. Something slanted. Something slanted. Okay, one vector is here, 8 Newton. Other one is just 10 Newton. But these two are separated by an angle of 30 degree. I need you to find out the resultant force. So now write this as a question. The following two forces of 8 Newton and 6 Newton, 8 Newton and 6 Newton apply on a certain object. Apply on a certain object. Okay. Apply on a certain object. So the vectors are 30 degree apart. Vectors are 30 degree apart. 30 degree apart. Okay. Vectors are 30 degree. Many. කායික වෙලින්ද? මේ අවටනේ ඊයේ මම පොඩ්ඩක් බලන්න මේ මොහොතේ ඇති. ඔව්. හැබැයි ඕක ඉන්පුට් මම බලලාට ඇවිල්ලා බලනකොට මිසින් වෙලා තියෙයි. දැන් මම බලන්න. Okay. So what did I say? For 2 Newton forces of 8 Newton and 6 Newton apply on an object with an angle of 30 degree apart. Find out the magnitude of the resultant force. Magnitude of the resultant force and the magnitude of the what? And magnitude of the angle of the resultant with 8 Newton force. Before doing this, I would like to remind you certain theory you have learned. It is like when you have a vector P and when you have a vector Q, which is certain theta degree apart, you used to find the resultant using a certain equation like this. But R square equals to P square plus Q square plus 2PQ cos theta. You have to use this equation to find out R. We have done this a long time ago. I'm just going to remind you. So if you want to find out the value of angle of the resultant with any given vector like this, so you are going to construct a certain triangle like this. This part is it is like P here, P sin theta, and this is Q, and this is P cos theta. So you get an answer here. Tan alpha, if the angle is alpha, tan alpha equals to P sin theta divided by P plus Q cos theta. Now tell me if anybody has forgotten this. I will re-explain this one with proper diagrams. I'm just reminding factor only. So that's why I just draw it in a very simple way. But if you have forgotten this, I will give you a proper explanation about this. Drop me a message if you have forgotten this one. I will give you 20-second appealing time. Then I will draw proper diagrams and apply this and show you if you have forgotten. Seems like nobody has forgotten it. Can you explain it? I have forgotten, sir. Okay. There are people seem to forgotten about this. Okay. Forget about this one. Have a good look at. If there is a force vector P and there is another vector Q. If these two are at an angle of theta degree apart from each other, you want to find the resultant. So you can create certain parallelogram like this. Certain parallelogram like this. Okay. And this is also Q. So you can construct, this is the resultant, this triangle here. If this is P, this is going to be what? P, this is the same theta. So opposite side over, this is the hypotenuse. When you consider this triangle only, see, P is the hypotenuse. This is the opposite side. So the theta is here. Opposite side over hypotenuse means sine theta. So this is going to be P sine theta. This part is P cos theta. So I will write like P sine theta and P cos theta. This angle is the one known as alpha. Now, when you want to find out the resultant of this one, we derived an equation. I am not going to derive it again. It is like P square, P any value of this square, adding with any value of Q and U raised to square and 2 times the P value, Q value times cos theta. Okay. This is what the equation we use to find out the resultant. Right? Now about finding the angle, let me draw this triangle only. Okay. Alpha. Now this angle alpha. This is R. This is what? P sine theta from here. P sine theta. And this is what? Q. This side is P cos theta. Okay. Give me a 1 minute. The mosquitoes are there. Wait. Can't put it on. Okay. Have a good look at R, Q, P cos theta, and P sin theta. This is 90 degree. So this whole side is Q plus P cos theta. Understand? Okay. Now I know this side and this side well. So what can I do? Tan alpha, angle is alpha, equals to opposite side, and this is the adjacent side. So when you have this thing, Q plus P cos theta, this is the adjacent side, P sin theta, this is the opposite side, and an angle of alpha. Opposite side divided by adjacent side will give you tan theta. So tan alpha is what? P sin theta divided by Q plus P cos theta. If you have forgotten, please take a screenshot of this one and save it. Please take a screenshot of this one and save it. Okay. Have a screenshot of this one and save it if you have forgotten it. No. It is P sin theta divided by Q plus P cos theta. It is P sin theta, not Q sin theta. Okay, Ramai? That's enough, I think. That's enough. So don't write, have a screenshot only because time is very important. If you miss to take a screenshot, watch the video and get a screenshot. My main priority is to show you how to apply this in the course. I told you one is 8 Newton, one is 6 Newton, and the angle is 30 degree. And you are finding the resultant as well as this angle alpha. Okay. Now from the initial one, what is the equation I am going to apply? R square equals to P square plus Q square plus 2PQ cos theta. Okay, I can take anything as R. I am going to take 6 as R. 6 square plus other one is 8. 8 square. 6 this and 2 is a constant. 2 P is 6 and Q is this 8. And cos theta, what is the value? Cos 30. Theta is 30. Cos 30. Cos 30. Okay. Cos 30. Let me just write it down. 36 plus 64 plus 2 times 6 times 8 times cos 30 means root 3 over 2. Cancel off 2 and 2. So I asked you to remember the values of root numbers. Can you remember? This is going to be 100 here and 6 times 8 is 48. So what is the value of cos 30? Is root 3 over t. So root 3 I told you to remember it as 1.7. Can you remember? Can you remember? I told you to remember as 1.73. Okay. So you just need to multiply. Let me use my calculator. Okay. Let me use my calculator. It is R square, my dear. So let me multiply 48 multiplied by 1.73. You can do it manually because I'm just trying to save the time. That's why R square equals to 100 plus 83. So R square is 183. Okay. I don't need R square. What do I need? I need R only, not R square. R equals to square root of 183. R is going to be, let me check, square root of 183. The answer is 13.52 Newton. Okay. 13.52 Newton. You might be wondering, sir, we are not allowed to use calculators in the exam. How are we going to take the square root of these things? So I told you, you will get this question in a specific way. I will tell you that the way in few seconds, few minutes. Okay, few minutes. What is that specific way? Okay, so here, copy this one, please, one by one. Okay, Lamai, quickly. Okay, quickly. Now, I'm going to erase this. I give you another 20 seconds for you to copy this one. Okay, let me erase. Let me erase. Okay, Lamai. Now have a really good look at. Very good look at. I'm going to find the answer. Tan alpha equals to P sin theta. P means P sin theta divided by Q plus P cos theta. Okay. P 6 sin 60. Sorry, 30 divided by, here the value is 8 plus 6 cos 30, right? Tan alpha is equals to 6 multiplied by half, sin 30 is half, 8 plus 6 multiplied by cos 30 is root 3 over 2, root 3 over 2, this 3, this is 3. So my answer will be tan alpha is equals to 3 divided by 8 plus 3 root 3. So let me get this number. Tan alpha equals to 3 will be 3, 8 plus 3 times 1.73. Okay, let me apply the values here. 3 by 1.73, you can get this one manually. 5.19 nearly 5.2. I will write it like 5.2 plus 5.2. So that means 13 divided by 13 point, sorry, 3 divided by 13.2. Right. Let me get that value. 3 divided by 13.2. 13.2. I will get an answer 0.27, sorry, 0.227. 0.2272. My answer for that one is tan alpha is 0.2272. This is what the tan alpha value. But I don't need the tan alpha value. What I need is alpha. Alpha is 0.2272 tan inverse. You have to check this in tan tables. we don't have the access to tan tables right now. I will do it in my calculator. Tan inverse arctan that of 0.2272, and I'll get an answer that of 12 degree 48 minutes angle as 12 degree 48 minutes. 12 degree 48 minutes. Copy this entire answer. You started from here, you came to here, and you again start from here. Sorry, you started from here, then going to here, you came to here, you got this answer, you got to here, you finally get to here. Copy from here to here to here to here, then again here, 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 and here. Okay, Lamai? I hope you understood it. I hope you understood it really well. You understood it, students? Okay, ne? Right. It seems very easy for you, most of you. It seems very easy for most of you because we need to apply the knowledge of this one in this particular lesson. Okay, copy this one. I will show you how it comes in exam. How it comes in exam. I'm going to show you how it really come in exam. Quickly, Lamai. Quickly. Come on. Did you copy this one? We need to do it, hurry up. Enough? I think you have a doubt, but still I'm having a doubt that q sine theta over b plus. Yeah, you can start like that. If you get q up, so if you get q up, you can get that way. If you get p up, you can get that way. Whatever the number you put, whatever the symbol you put, if you put p to here, your result is like this. If you put q to here, your result is like this. We had, and I taught you in my lesson, and if you want, I can share you that recording, and you can rewatch it and understand. Okay. Let me erase this one. Now, right, for the exam, it normally comes like in the following way. For the exam, it normally comes up in the following way. No, it is interchangeable. Okay, here, have a good look at. You will find this one in perpendicular to each other. 8 Newton, 6 Newton in the A level. In the A level. You want to find the resultant, you need to find out alpha. Now, right, quickly copy this one. Quickly copy this one. Write this in a new line. For convenient, For convenience, we can rewrite, redraw it in the following way. Okay. 8 Newton. Okay. I told you now, in a vector, you can keep that vector parallel to that system in anywhere, to the right, to the left, to below, to up, whatever in the parallel. So I'm going to move this vector to here, this 6 Newton to here. You can. Parallel to anywhere. You can't change the parallelity, but after parallel, you can keep it in anywhere. Reaction is here. Resultant is. Now, horizontal and vertical, they are perpendicular. Now you can apply what? Can apply what? Can apply. What can we apply? What can we apply now? When it is a right angle triangle. What can we apply? We can happily apply Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. Here we can apply R square equals to B square plus Q square only. I'm going to get it up here. R square equals to 6 square plus 8 square only. R square equals to 36 plus 64 only. R is equals to 100. So R is square root of 100. What is the value of square root of 100, my dear? Just 10. R is 10 Newton. Okay. I told you in the exams, you will find all the forces perpendicular. They don't give other things because we don't have the calculators. But we have to practice everything. So there is a really good example question, a past paper one, that is belongs to projectile motion. Here, wait. Here, this 2002 question here, in this part, you have to apply that knowledge and find out the resultant. You will understand, oh, vectors very easy. That's it. You will never want other ones. Okay. Okay, my dear students, that's done. Now it is about finding alpha. Tan alpha is equals to P over Q only. This is P, this is Q. Q over Q only. Tan alpha is equals to 6 over 4, 8. So it is like 3 over 4. So tan alpha equals to 0.7500. So I need the alpha. Alpha equals to 0.75 tan inverse. So let's find it in from the logarithmic, what is it called? Tan tables. We don't have tan tables. So I'm going to use this one. In the exam, they will given it printed though. So you will be given tan tables. It is like 36 degree, 52 minutes. 36 degree, 52 minutes. Isn't that pretty easy? Isn't that pretty easy? Very easy. Very easy. I will send you a midweek worksheet to do all of this type of rememorizing lesson and also try to find the answers for the live worksheet I gave you. So you may have to search something in the internet and finish everything in the live worksheet. You can do it. It is very simple. Try that and I will send you example, midweek worksheet including projectile even projectile and these ones together. I told you until to like next 2 months, I will be adding projectile questions as well. So I keep reducing, and after 2 months, I'm not going to add any projectile. I'm pretty sure within 2 months period, you will get to know all the secrets of projectiles. And I will randomly discuss these projectile questions in this class even. So I sent you a certain paper last week. This is not a midweek worksheet, finishing worksheet, and it included term test papers. In grade 12, you could see there were about 4 to 5 Mawson related questions in each school, like Royal College, Maliyadeva, and other big schools. And even in the Jaffna and Northern Provincial and the zonal papers, they are really standard, and also with Northwestern Province papers. I included almost like 25 questions. So in those, you could see in the first term, there were 4 to 5. And actually in the third term, in grade 13, that means the final term test, there were only like one MCQ and no MCQ at all from any Mawson question. So Mawson is a very small lesson. So now enough of practicing it, only very simple things will be asked from it. So you just keep rememorizing practices, that's okay. But we have big lessons to do. Fourth lesson is a very big lesson. That is why I taught you down to deeper and simple points today. My teaching style also I changed today. Why? I want to give you very basic knowledge of this. Because it is something really, really, really essential. Okay? I hope you understand what I'm telling you. From the next week onward, we will have more calculations. Today, we didn't have much calculations, very simple ones. Tougher ones will be there from next week onward. So really good series are there also. So you will have to get used to everything, right? I hope you understand what I'm telling you. Ne? Okay, students. I think it is time to wind up the class for today. God bless you all. Bye, Ramai. Class is over. Good night. God bless you. Bye. Class is all over. Bye, Ramai. Okay, bye. God bless you.